So yes, I expect people to despair. I mean, it's horrifying, it's horrible. Dealing with our own death is difficult enough in this death-denying culture.
Mm-hmm.
But to deal with everybody's death, that's a heavy load.
Hi, welcome to Peak Moment. I'm Janaea Donaldson. Late in 2012, we watched a video by Guy McPherson about climate chaos. I was stunned, and I immediately called Guy to see if he could talk with us, and I'm glad he's here today. Thanks for joining us.
Thanks for having me on the show, Janaea.
Guy is the Professor Emeritus of Natural Resources and the Environment at the University of Arizona for 20 years, and a conservation biologist, and an author of 13 books, including Walking Away from Empire and Going Dark. And your blog is Nature Bats Last. We'll catch up on those things. So thank you. Thank you for being here.
It's my pleasure.
I see you as an independent scientist at this point, not being beholden to a university, to an organization, to money, to the government. Having taken on a rather daunting Paul Revere-like calling to bring together the data on climate chaos that we aren't seeing, or it's hidden away from the mainstream. Tell us what most of us don't get to see.
Well, I was 20 years in active service at the University of Arizona, and I left about 5 years ago. And subsequently, that has liberated me to pursue information in ways I didn't have time or cultural incentive, we'll say, to pursue when I was in active service. There's a lot of self-censorship that goes on in this society, and it happens at universities too. Imagine that. So, of course, I didn't have time, interest, inclination to pursue the kinds of information I've been pursuing since then. It was 2002, I was editing a book with a colleague on climate change, and I reached the conclusion that we were headed for human extinction in 2030 or so.
Wow.
And there was no good reason for that. We certainly didn't have the data, the models, the information.
No.
So I suppose it was largely intuitive. And then a year or so later, I discovered the concept of global peak oil, and I realized that it's a Hail Mary pass, that the set of living arrangements might go away in time to prevent our own demise in the near term. Well, that was a long time ago. And civilization has not been terminated, has not ended. So it just keeps going and going and going. And so now we've triggered 30 self-reinforcing feedback loops, positive feedbacks. An informed analysis of one of those indicates that we're looking at 4°C temperature rise above the beginning of the Industrial Revolution by 2030, and 10°C by 2040. And that's just one. That's methane being released out of the Arctic Ocean. There are 29 others. And you multiply all those together, and they're multiplicative, not additive. You multiply all those together, and it looks like that we might indeed not have long as a species on this planet.
That's not, I mean, that's what stunned me. It's like you can't wrap your head around that near term human, and not just human, extinction is inconceivable. It's like it's unthinkable, and we'll talk later about how does one respond to that, from the inside. A question that I have for you is, can you, obviously you do long presentations, and you've also got an evergreen document where you're keeping track of studies, data, and I noticed that a year ago you had maybe 15 or 16 on that list. And just in this 1 year, more factors that are, seems to be going exponential with more and more data coming in.
That's right. We triggered the first self-reinforcing feedback loop reported in the scientific community, in the mainstream scientific community, was methane leaking out of the Arctic Ocean.
Okay.
in March 2010, as reported in Science. That was the only self-reinforcing feedback loop reported in 2010. 2011, there were 4 more. 2012, there were 6 more. 2013, 16 more.
Wow.
And so far, here on February 23rd, 2014, we know about 1 additional one. And we know a lot more about those earlier ones. So the science is starting to catch up with reality, essentially. And so we're starting to accrue evidence about each one of those self-reinforcing feedback loops. And you're right. A year ago, there were a dozen or so. I delivered a presentation outside of Amsterdam in early August of last year. So, less than 6 months ago.
Yeah.
And we were at 19, and now we're at 30.
Which is inconceivable.
Geological events are playing out in real time at this point.
Can you give our viewers some highlights from what you're presenting so that they can get, a sense of the data that's telling us this?
Yes. Well, we know that it's 40 years from cause to effect, 40 years from greenhouse gas emissions until temperature rise. So the temperature rise we're seeing today is a result of emissions in 1974.
Okay.
And so that there's a couple of things that are important about that. One, we are not going to slow down this train. The emissions from the last 40 years have not caught up to us. In fact, we've emitted more greenhouse gas emissions in the last 29 years than in the previous 236 years combined. Those 29 years, they're not even baked in yet.
Right.
I mean, they're baked into the cake, but they're unaccounted for at the level of the temperature.
Okay.
Another really important facet of that is that emissions from 40 years ago are being exhibited with temperature rise today. I don't know about you, but I don't feel particularly guilty for things I was doing 40 years ago when I was 13 years old. Yeah, I didn't know, and as almost no individuals in the society knew where we were headed 40 years ago and thought relevant action would have something to do with terminating industrial civilization.
Right. I think that there's also a lot of unintended consequences that we don't know. We're clever, as clever apes, and like to experiment, and so that oozing black stuff that came out of the ground, what might it do? Here we are.
Well, yeah, it's incredibly attractive. I mean,
and it's fun, and it's interesting, and it's,
of going after that
course.
technology and burning those fossil fuels, and it makes life wonderful.
Of course.
In the short term,
of course.
For us individuals.
Of course. So we've got the temperature lag going to accumulate and hit us. I mean, increasingly every year, right?
That's right.
And there are other feedback loops as well, other things that are. What I think you said here is we are on course to be at, you tell me, a higher level number of degrees C warming planetarily, even by 2030 or 2040.
Well, yes, based on a single feedback. That of methane released from the Arctic. And methane is coming out of the Antarctic, and methane is being released from the permafrost, or the permamelt, as we really should properly call it now. And just one source, methane from the Arctic, from the seaflow in the Arctic, leads us to foresee a temperature beyond which humans have ever existed on this planet.
That's what I was going to ask you. It's
by
like
2030.
4C doesn't sound like a lot, because, it's the difference between, say, Alaska and LA, but why is that? Humans have never existed at that hot a planet.
We haven't existed at 3.5C above baseline, above the beginning of the Industrial Revolution. Why? Because all kinds of weird things started happening when you heat up the temperature to a certain amount. So when we came out of the Ice Age, out of the Pleistocene into the Holocene, the temperature warmed a couple of degrees C, and that temperature rise, which subsequently stabilized, probably accounts for our ability to develop civilization. Civilizations arose several places around the globe at about the same time, a few thousand years ago.
Okay.
Probably because temperature became stable and warm enough to grow grains.
Okay.
So that's a hallmark of civilization, is the ability to grow grains and then store them, and therefore control the food and get you through the hard winters and so on.
Yes.
And So if civilization was locked in, and I'm not sure it was, but it's been locked in now for a few thousand years, then industrial civilization is just a step further, one more step towards that convenience of having stuff we like.
Right, right.
And so here we are, sort of unwilling participants in this system that takes us to the abyss, and that almost nobody knows we're even headed for the abyss.
Right, which is what we're talking. I want to go back to you saying a lot of things can happen at that, as we get beyond the 3.5 degrees C, like.
Right, well, we're already seeing at 0.85 C above baseline. We're already seeing polar vortex.
That's where we are now, 0.85 above?
Yes.
That's all.
Yes. And the United Nations Advisory Group on Greenhouse Gases warned us about exceeding 1 C in 1990. They said that's truly dire and catastrophic. And James Hansen has joined that party just within the last couple of weeks. He switched from 2 C being truly catastrophic to 1 C is going to do serious damage. Well, I think we're already done. If 1 C was the target, then 0.85 C is close enough that it's taken us
Right.
over the cliff, as it were. What kinds of things do we see from that? Well, we see high temperatures, locally high temperatures, that are sufficient to cause proteins to denature and therefore kill plants. Well,
There goes agriculture.
yes, bingo. In addition, you see temperature swings that are so severe. Here's an example. I lived in Tucson, Arizona for more than 20 years. 2 of the last 4 winters have been so cold that 80 to 100-year-old citrus trees died in Tucson, Arizona. 2 of the last 4 years in Tucson, because the jet stream is meandering far greater than it used to be, because the temperature gradient has broken down between the Arctic and the Amazon, between the Arctic and the equator. So now that jet stream, which just blow across Canada and the northern United States with these cold fronts, and they'd sweep across the country in 4 or 5 days and be done with it. Now we have the jet stream meandering with this huge amplitude and dragging cold temperature from the Arctic down to Mexico City and destroying all the vegetable production for winter vegetables as far south as Mexico City. So those are the kinds of things that are going to lead to our extinction as a species, are these extreme temperature events, including extreme high temperatures that denature proteins, and temperature swings, including cold temperatures that kill land plants. In addition, we're acidifying the ocean to such an extent that we're killing the phytoplankton. Phytoplankton are the base of the marine food web. Without phytoplankton, without significant numbers of phytoplankton, we don't get any food from the ocean. We might have jellyfish, a few.
Doesn't sound real appetizing.
Yeah, no, not at all.
So what you're saying, if I hear you right, is that what's going to lead toward that extinction of humans primarily is the destabilization of the environmental factors for food growing.
That's going to be a really, really big one. Now, where I live, in the southwestern interior of a large continent in the northern hemisphere, the most rapid place to warm up, probably what will happen is the temperature will rise to 130 or 135 degrees Fahrenheit one of these days. It's not that great a difference over the historical record. And that will denature the proteins in all the plants, and so all the plants will die. And then the wind will start blowing, and we'll have the Dust Bowl that never ends. So me and my neighbors and everybody who lives there will literally choke to death. If they don't die from the food, they'll die from the inability to breathe.
Dust and breathing.
There are thousands of people who died in the Dust Bowl in the 1930s because they were breathing in more solid matter than air.
So is there anything else on the story of the factors leading towards extinction that you want to share here?
Well, there are a couple of things that I think are pretty important. There's this contrarian view that the temperature has stabilized within the last 15, now 16 years. 1998 was the hottest global temperature year. And so that's based on land surface records. But as it turns out, a paper from about a year ago points out, in geophysical research letters, points out that heating has actually accelerated. It's just been hidden in the oceans. So the oceans are heating up. Well, the oceans, as you know, account for over 2/3 of the surface area of the planet. We just have our thermometers on land, so we missed this.
So it's just the oceans are soaking it up, getting more acidified, and who knows what else.
Yes,
You know,
and also getting a lot hotter, in addition to being more acidified. So what that does is it releases methane, for example, from the Arctic Ocean. So we can take a look from a couple of weeks ago at methane concentrations in the atmosphere, and you can see they're concentrated in the northern hemisphere. This dark red is a lot of methane. At the beginning of the Industrial Revolution, we experienced about 700 parts per billion, 700 parts per billion methane in the atmosphere. We're now at routinely over 2,000 global average, 2,000 parts per billion. And last week, earlier this week, just a couple of days ago, we were at about 2,400 parts per billion in some recording stations.
So that is changing the is it about changing the atmospheric composition, or is it just about the heating? I mean,
that's a result of heating,
right,
releasing the methane into the atmosphere. And methane is more than 100 times more powerful a greenhouse gas than carbon dioxide in the short term, in less than 20 years. So every part per billion of methane in the atmosphere is a really, really big deal. And so that leads to acceleration. So you know, these self-reinforcing feedback loops, they self-reinforce. It gets warmer, more of the methane emerges. More of the methane emerges, it gets warmer. It gets warmer, more of the methane comes out.
Runaway.
Yes.
That's runaway and nonlinear.
Yes.
Are things that you're saying. This is like, it's a complex system, all kinds of things tying together, but it's on runaway.
That's right. And this runaway event is the sort of thing James Hansen worried about in his book Storms of My Grandchildren, and didn't think it would happen in the near term. But that book came out long before we knew about these 30 self-reinforcing feedback loops, and we had evidence that we had triggered them. So the acceleration is astonishing.
Yeah, it's boggling. I mean, I've been keeping an eye on it since 76, but 1990 more so, when I read McKibben's End of Nature. And it feels to me like the last 2 or 3 years, it's like, it's feels exponential to me.
Well, I update regularly an essay on my website, Nature Bats Last, the climate update and summary essay, and I updated it again this morning, and I have to update it every few days because the information just keeps pouring in, and I ran across 2 more journal articles that came out within the last few days. And it's never any good news.
No, I noticed that. It's like nobody is saying, oh, it's not as bad. Tell us about this piece.
So planetary scientists for a long time assumed and reported that Earth was in the middle of the habitable zone for a star the size of our sun. So that's the sun. Here's Earth, and we thought we were right in the middle of this green zone, the habitable zone. It turns out a paper in Astrophysical Journal last year, March, points out that actually Earth is right on the inner edge of the habitable zone, which indicates that if we change the atmosphere ever so slightly, we could push ourselves out of the habitable zone. We could push ourselves towards Venus, which is, toward the sun a little bit.
Yeah.
So Mars, Earth, Venus, about equidistant. Venus is not shown on this figure. But Venus is right there. Well, it turns out that we have not changed our atmosphere a little bit. We changed it a lot. And we were barely, we were within 1% of being uninhabitable. And so we've now altered the atmosphere to such an extent that I can't even imagine that we have not triggered runaway as a result of that large change in atmospheric chemistry, and in a planet that was very close to the
close to the edge anyway.
Zone anyway.
Yeah.
Right.
I mean, what you're saying is there are people who say, well, civilization go down, humans may go down, but the Earth will survive. And what you're saying here is not necessarily.
That's right.
Life may not continue on this planet.
That's right.
Because of this one
because,
species.
as we know, Venus went Venus. Yeah. And if we look at an exponential, an analysis done by Malcolm Light, December of last year, where he actually applies an exponential function to methane release and in the Arctic and consequently temperature rise, He takes us to temperatures similar to Venus in 2096. That's this century.
I want to
So we're not going to do well in that sort of environment.
I think that's true, and that's staggering. I mean, it's
Mm-hmm.
something that, how do you, when you first had that intuition and began gathering the data and it began to just validate what your intuition was, I mean, how did you take that? You know, I'm talking about how do you respond inside to this?
Poorly. You know, I was much younger than I am now, for one thing, and I mourned, obviously, for our species, and it was strange because people couldn't understand that. It's such an abstract concept.
Yeah.
I'm a conservation biologist, and extinction is not merely an abstract concept to me, because I've been documenting the demise of other species for a long time, and so it's not just abstract. But people couldn't understand why I would have so little empathy for their dying 85-year-old grandmother who had a full and rich life and 7 children. But I was mourning this other thing that they can't even wrap their minds around. And that was not the first thing that made me social outcast, shall we say? But it was yet another indicator that I was thinking a little differently than other people. So I mourned for months, and nobody even noticed. And it took me a long time to deal with that, a really, really long time, in part because I didn't seek therapy for it, and probably no therapist would have understood anyway what I was going through, because it's so unusual, it's so strange. And then a llama in Winnipeg, Llama Jerry, saw a 4-minute film clip shot by Pauline Schneider, who's making a movie about my efforts. And in this 4 minutes, he said it became obvious that I had reached a point of acceptance. That up until that point, I had been angry, confused, lashing out, frustrated. I was experiencing all these emotions. And then he said, in October of 2013, you finally let go. And you became a much more centered human being. He said, I saw that, and his response was, I have to get him up here. We need to talk.
Does that match your experience of yourself? What he named there?
Yes.
Yeah. So
yes.
you moved.
I didn't have any identifier, tag, no moniker to put on it. I just knew I was a different human being than I was weeks earlier. And part of that was because I realized that it's not my fault. You know, as a lifelong teacher, I assumed that it was my job to teach everybody in the world what they need to do. And of course I was the teacher, so of course they would listen to me and they would do what I told them. I mean,
and it's not your fault that the IPCC and all the governments of the world and that all the people of the world don't hear this and get it.
Right. And it took a long time. I had to walk away from teaching and spend nearly 5 years away from it to realize that I can't change the world. It's all I can do to change myself, and not necessarily in a good way. And so I need to let go of this notion that I can, you know, with a pair of tights and a cape, save the world. I can't, and I don't even have the tights or the cape. And so that made me a lot more relaxed about it. Also, you know, the 40-year lag between cause and consequence is yet another piece that says it's not your fault. You know, 40 years ago we didn't know, you didn't know.
Right. Right.
And so we're trapped. So let go or be dragged. And so finally I did. Interestingly, this Lama, his teacher had all of his students, as one of their final lessons, watch a body decompose. And so he told me that, and he said, you've been watching the body decompose. You've been watching the body decay for a long time.
Yes, yes.
So finally, you've reached this understanding of impermanence. And awesome analogy. I learned so much when I spent a few days with him and his Dharma Center group.
So when you present this information to audiences, and I'm sure that people are also, you know, rocked by, deeply moved by this possibility that not only that it's happening on our watch, that we're looking at the end story on our watch, likely, and that the young people of today, what kind of future are they going to be? You know, it was already up in uncertainty, and it's even more uncertain. What kinds of what will I say, advice or perspectives do you give people about how do we live through this?
Well, I frequently point out the line from Edward Abbey, the iconoclastic writer from Tucson. Action is the antidote to despair. So yes, I expect people to despair. I mean, it's horrifying, it's horrible. Dealing with our own death is difficult enough in this
Yes.
death-denying culture. But to deal with everybody's death, that's a heavy load.
And every animal you know, and every bird you
Right.
know, and every fish that is, and a lot more.
Right, yes.
Everything
It's
that's living.
Yes. We're destroying every aspect of the living planet. And that's horrifying and grief-inducing if you care, if you have any empathy at all.
Yeah.
And so what to do? What to do about that? Well, we could crawl in a corner and do nothing. And or we could just continue with business as usual, and that's what most people do when they
Yeah.
their takeaway from my message is, well, we're all going down anyway, so I'm going to keep doing what I've been doing, even if it is a job I hate, because I feel like I need to earn some money and save for retirement that will never come, and all that. And so the advice I give is to let go. The action is the antidote to despair. So let's do something. If you're damned if you do and damned if you don't, then do. In fact, I think this is incredibly liberating.
Yeah.
If this is the end, then why don't you not do what culture screams at you to do? Why don't you do something different instead? I think it's incredibly liberating because we don't have to be bound to culture anymore. If we're the last human beings to occupy the planet, and I strongly suspect we are, then why don't we exhibit some humanity for a change?
And maybe an exalted kind of humanity, if you will, at our best. You know, giving the kind of compassion, the random acts of kindness, as you say, go and liberate a stream, you know, find what we love, you say. It's a good one. Find what we love, or where we love, or who we love, and serve that.
Yes.
Share it.
Yes. So when I see and read about people in hospice, and I think we're all in hospice now, when I see the actions of those people, I don't see money grubbing. I don't see people accumulating shoes. I see people giving things away. I see people acting with the kindness and compassion for which humans are renowned, and in which we respect in human beings. And so I think that's great. These are people who are accepting their own deaths and integrating it fully. And how do they act? They don't act like the banksters on Wall Street. They pursue love. They do what they love. They pursue lives of excellence. Let's do that. I suspect we get to see the end of this movie. And nobody else in human history has got to see the end of the movie. And they walked out, they left. The power went out, whatever. They didn't get to see the end. We get to see the end. We get to see how humans act in the face of their own demise. What could be more exciting than that? What could be more humane than that?
What a call to the best in all of us.
Right.
Thank you.
Thank you.
The call to the best in all of us. That's what a peak moment is. Join us next time. I'm with Guy McPherson. I'm Janaea Donaldson. Thanks for watching.